So my apologies if you hear vehicles in the background. I was just coming from work and I had to stop so that we can have this class. Um, Today we are looking at measures of central tendency. We're looking at measures of central tendency. So in quantitative research, we deal with numbers, and because of the fact that we deal with numbers, we must be able to analyze those numbers. We must be able to find sense out of those numbers. But most importantly, when you're looking at numbers, want to see what is more representative um, in terms of those numbers in relation to the population from whom we've collected data. So that is what measures of central tendency is all about. We're looking at the central location of values which can represent a sample. So definitions, measures of central tendency are statistical measures which describe the position of a distribution. So when you talk about distribution, for example, out of 9 people, I collect their ages. This one is 24 years old, the other one is 21, the other one is 50, the other one is 46. So that is a distribution, okay? That's a distribution. So it's computable values on a distribution that discuss the behavior of the center of a distribution. So what is the center of this distribution? You've got different ages from maybe 5 years old, 7, 8, 11, 9, 21, 34, 32. How is the behavior when you look at the numbers? So the value of the figure which represents the whole series is neither the lowest value in the series nor the highest. It lies somewhere between these two values. So we have the median, we have the mode, we have the mean. Okay, so the average represents all the measures. So here we're talking about the mean itself. Here we're talking about the mean. Okay, when 2 or more groups are measured, the central tendency provides the basis of comparison between them. When we talk of the mode is the most frequent value or score in the distribution. Mode, so something that can remind us of what mode is. Imagine that D is an R, so it will be more. So what number is appearing more often? For example, age of kids in a class, there's 2 years old, 1 year, 2, 5, 4, another 2. So I've mentioned the 2 3 times. That 2 is the mode because it appears more frequent than any other number that I have mentioned here. So mode is readily comprehensible and easily calculated. So it's easy to just see on a distribution which number is appearing more often. Also, it is the best representative of data. So because many are in the age 2, so that 2 represents more for that particular distribution. It is not all affected by extreme value. So for example, there are 5 kids, 3 of them are aged 2, 1 is aged 3, and then 1 probably with an intellectual disability is aged 15. So that 15 won't influence that distribution in terms of representative. So we can say that the mode is 2. And really we have got 3 kids who are 2 years old. Are we together? Let me know if I lose anybody at any time. So the mode also can be determined graphically, which means you can be able to make a graph and see which value appears more. Think about a hospital setting, department setting, where you're looking at different patients. So you find that those with stroke, maybe they are the most. So that becomes the mode. Okay, there are some disadvantages of mode. It is not based on all observations. Okay, so age 2, age 2, age 2, somebody else is 3, the other one is 15. So it's not really based on, it doesn't take into consideration the other values, which could even be bigger. So it is not capable of further mathematical manipulation, so you can't do any other calculations out of that. Mode is affected to a greater extent by sampling fluctuations. So imagine we had 5 kids in that classroom. The moment we go to another classroom, you may find that in that other classroom, 4 of them are aged 3. So when we add those ones to our group of participants, you find that the mode changes. Then the next is the median. Median, think about the word middle. Okay, median is a central value of the distribution, or the value which divides the distribution in equal parts, each part containing equal number of items. Thus, it is the central value of the variable. So think about these kids I'm talking about. One is aged 2, another one is aged 2, the other one is also aged 2, then there's one aged 3, and then another one 15. So the first thing that you need to do when you're calculating the median is to place the numbers in ascending or descending order. These are maths we did, I think, in grade 10, grade 9, or grade 10. So it should be easy for us. So the first thing, you put them in descending order or ascending order. Then you look at what is the value in the middle. So 2, 2, 2, 5, 15. So the number which is right in the middle is 2. So 2 becomes the median. Sometimes you find that the number of items in a distribution have are even, which means, for example, 10 is an even number, 12 is an even number, which means that there'll be 6 values on your left and 6 values on the right. You won't find a number which is right in the middle. So in that case, you look at the numbers in the sides. So you go to the middle point, there'll be a value on your left and the value on the right. You add those 2 values and divide by 2. That becomes your median. There are advantages and disadvantages for using median. Number one, median can be calculated in all distributions. So no matter what kind of a distribution it is, you will be able to find a median, whether it is just there in the case of odd number of items in the distribution, or where you add the 2, which are in the middle of the distribution when it comes to even number of items in the distribution. So median can be ascertained even with extreme items. So there could be a case where the majority of the individuals in that distribution are aged between 20 and 26. Then you find that within that group, there's one person who is aged 89. So that big age, when you're identifying the median, that big number won't affect your result at all, or what the median is. It won't be affected. It has some disadvantages. It is not based on all the values. You just look at the value in the middle. Okay. It is not capable of further mathematical treatment similar to the case of the mode. And it is affected by fluctuation of sampling. So, for example, we increase the sample size, we add in more individuals, so the median may actually change. So, like I mentioned, that in case of even number of values, it may not be a value from the data. So you may find that you end up having, for example, if the values that you use to calculate, one is 21, the other one is 22, so you can end up with 21.5. That 21.5 may not be appearing at all in that distribution. And then, of course, the other part of the central tendency, it is the mean. Mean is average. All of us understand average very well. So you add all the values and divide by the number of items. So in the case of those five uh, 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 children in that class, there's age 2, age 2, age 2, age 5, age 15. You add all those numbers, 2 plus 2 plus 2 plus 5 plus 15, and then you divide by 5, which is the number of items within that distribution. So easy calculation. And in the test, which I've already prepared, which we'll be having very soon, week after, you will have to do some calculations. There are some advantages of mean. Are we there? Are you able to hear me clearly?
Yes, Doc.
Okay. Sasindala is saying that he can't hear me. He can hardly get me. So you let me know if there's anybody else other than Mr. Sasindala who is not able to get me clearly. Otherwise, I am recording this presentation and I will post it on my YouTube channel so that you can always revert to it. So the advantages of average, it is easy to understand and simple to calculate. So anybody you ask what is the average age, somebody can easily add those and divide by the number of items in that distribution. And then also when you look at the mean, it's more representative of everyone because all values are added, come up with the final value. It is rigidly defined. It is just what it is because you're adding everything and then dividing by the number of items. It's easy to understand the arithmetic average, even if some of the details of the data are lacking. It is not based on the position in the series, so it's not like the way it is with median, where you're looking at the position. No, it's about everyone's value being added. It has some disadvantages. It is affected by extreme values. So look at the example I gave you where one is 2 years old, the other one is 2 years old, the third one is 2 years old, the other one is 5 years old, the other one is 15. That 15 is an extreme value because it's quite far from the other four individuals in that distribution. So it will affect, you may find that the average is more than 5. It'll be 6, 7, somewhere there. So also another disadvantage of mean is that it cannot be located graphically. All right, it cannot be located graphically, and also it gives misleading conclusions. Okay, especially when there are few values in a distribution, like the one I gave. I can even give an example of a more extreme one. One is age 2, the other is aged 3, the other one is aged 7, the other one is aged 4. Then the other person in that distribution is aged 86. So when you calculate the average age, when you say that population, the average age is 40, it will mislead somebody because you'll be thinking most of the people aged between 30 and 50, when actually we've got toddlers and we've got an elderly person in there. All right, I have some exercise for you. So I will be giving 3 minutes for each slide for you to just do some calculations. You'll be expected to do these calculations in your test as well as in the exam. So I'm giving you 3 minutes. So if somebody finds the answer, please feel free to mention the number. Which is it? A, is it B, is it C, or is it D? So C is correct. Here's another one. What number would you divide by to calculate the mean of 3, 4, 5, and 6? So the answer there is D. It's so simple. I wouldn't even take more time there. What measure of central tendency is calculated by adding all the values and dividing the sum by the number of values? What's the answer? What's the answer there? Yes, Muvanga, B is correct. Lizzie, yes, B is correct. It's the mean. The mean of four numbers is 71.5. If three of the numbers are 58, 76, and 88, what is the value of the fourth number? 3 minutes. Carol says A, 64. And indeed, it is 64. That's correct. A random group of patients at the physiotherapy department were weighed. The scores in kgs were 90, 50, 70, 80, 70, 60, 20, 30, 80, 90, and 20. Find the mean score. So the mean score there will be, we add all of them and divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we add all of them and then divide by 11. Here's another question. What is the median of the following numbers? What is the median? I'm giving you 2 minutes, 3 minutes. What is the median? Karo says B, and yes, it is B. Mwanga says B. B, Chawanzi, correct. So the first thing that you do is to arrange these figures in ascending or descending order. Then since these are even numbers, so the two numbers in the middle, you add them, which is 39 plus 39 divided by 2. So 39 plus 39, 78 divided by 2 is 39. Correct. Here's another question. The front row in a movie theater has 23 seats. If you were asked to sit in the seat that occupied the median position, in which seat would you have to sit? Anyone with the answer for that? Buwanga says D, 12. Yes, the value 12 is correct. Next question. What is the median score achieved by a student who recorded the following scores on 10 maths quizzes? So these were the different values or percentages that the individual scored, which is the median score. Yes, C is correct. C is correct. So the next part, these are measures of dispersion. Here we're looking at how far away are the different values from the midpoint. So measures of dispersion are descriptive statistics that describe how similar or a set of scores are to each other. Okay, for example, where we give 2, 2, 2, 5, and 15, how similar are they? How far apart or closer to each other they are. The more similar the scores are to each other, the lower the measure of dispersion. So dispersion is being away. The less similar the scores are to each other, the higher the measure of dispersion. So that number that denotes the dispersion is higher if the numbers are far apart, and it's smaller if numbers are close to each other. So in general, the more spread out a distribution is, the larger the measure of dispersion. So for example, in a group of learners in the first year, if most of them are aged between 19 and 22, it means that the measure of dispersion will be smaller. If you have in that class people aged from 17 to 35, 38, the measure of dispersion will be higher or wider. So there are different types of measures of dispersion. There's the range. Range is just the difference between the highest and the lowest value. In that class of those toddlers and one adolescent, so there the range will be, the lowest value was 2 years old, the highest was 15 years old. So there the range is 13. So it's 15 minus 2. So the difference between the lowest and the highest is 13. And then there's what is known as variance. And the variance is defined as the average of the square deviations. It's the average of the square deviations. Okay. So what does that formula mean? The one that I put up there. First, it says to subtract the mean from each of the scores. So this difference is called a deviate or a deviation score. So for example, if we have got 2, 2, 2, 5, and 15, we add them and then we divide by the number of items, which is 5. So the value we find is the mean. So the difference, if it says so, to subtract the mean from each